Okay, so we got the world's tiniest knife. Look at that thing. Can you even be tough if your knife is only that big? So it's bigger than we thought it was going to be, to be honest. Oh yeah, just boxes in there, huh? So we're unboxing this thing right now. Oh, you're going to scratch it, I bet.
No, that other dude already scratched it, remember?
Yeah, so hey, when these guys were assembling it, somebody scratched it already, but it's okay.
They signed it for us.
They signed it for us. We figured we would scratch it too, so you know.
Thanks, Jimmy.
Yeah. Any guesses as to what this thing is yet? Look at that. If you know, you know. Look at the fanciness. It did come with a table. I thought it was going to be the whatchamacallit. That thing. That's fancy. Oh yeah. So there you go. That's what we got going on here. So we are going to ramp up the production and start doing all of our stuff with this here welding cobot. So this has the CMT process on it, and it has the PWC, I believe. You can go on YouTube and check out Fronius. The weld quality of this machine is unreal. Like, I didn't think it was possible for it to be as good as it is. And then I went and saw it demoed, and it was like, holy cow. Like, this is a cool ass machine. So also I'm surprised, like, I didn't know that you could spend so much money on a machine that still had wire in it. Like, holy cow. So, but at any rate, yeah, so here's the key to the city. So I'm gonna quit rambling now, and yeah, I don't know where we're gonna put this thing, but it doesn't matter, right? So this is cool. All right, YouTube, talk to you soon. Okay, so we have, I know that I started this video right when we unboxed this thing and then made no updates. So we're actually here. Our boy Nick came out, hooked us up with some good instruction. We actually like made parts today. So this is really good. This Fronius unit is crazy. It does some really neat stuff. So we actually set this up. We programmed a spring plate from end to end. I'm going to simulate it. I've got the GoPro mounted on this thing, so it's going to run around in circles. It should be pretty neat. So yeah, I'm going to turn this thing around, and I'm going to run the simulation just so you can see with no sparks, and then we're going to add sparks, and I'm going to edit a video, and it should be pretty good. So no hesitation. Here we go. So this is going to be our simulation. So you can see this thing rolling in, doing the vertical, jump over, do the other vertical. That little noise that you hear, that is the wire sticking out. And so this is how you teach the power source where the distance is, right? So basically, it's setting like your Z height. So kind of a slick little deal there. Go. So we've welded that side. It's going to jump up, do a little rotation. We're going to do other vertical right there. Same kind of thing going on. So we left like a little tiny gap. So think about it like if you were just manually welding this thing, you would leave yourself maybe a little gap so you've got a spot for the filler material to go. So we kind of did the same thing. So you can see how perfectly it holds that distance. Jump up, rotate around, and then you'll watch it actually rotate the torch angle as it passes through the center line of the part. Rotate. Yeah. It's pretty cool to watch. There's so many joints in this arm doing so many things at once. Like a lot of calculation, a lot of stuff going on. Okay, so we're at 2 minutes and 33 seconds, and I started this video off with a whole bunch of talking, and we're already onto this gusset joint. Like, obviously, we're going to have to weld this thing in more than one piece, but this part will be 95% welded. I guess not 95. Let's call it 75% welded. I have to weld the 2 gussets on the side and then the top of the hold down, but we're now just wrapping up 3 minutes in, and we only have these two last welds for the back strap. So this is a massive time improvement from how we have been doing it, and it's no compromise on the quality and no compromise on strength, and it allows us to do other things with our time that's not just standing there welding for hours on end. So it's allow us to kind of lower overall product cost and develop new stuff without any drop in quality. So that was like when I was talking to these guys about 3, 4, 5 months ago. My main focus was that this stuff would be as high a quality as it was before, and yeah, I think we're easily going to achieve that. It's not going to be a problem. So this is slick, runs across, tags this all in, and there we go. 3 minutes and 52 seconds, and that was with me talking for a minute, right? So there you go. Returns up to home, and that thing's welded. So I'm going to go ahead and we're going to run this out of simulation mode and weld this thing up. Okay, here we go. Let me put my helmet on so I can see. So you can actually hear the sound difference. So the vertical down is programmed at a different speed and a different feed rate than or temperature, right? Like different amperage than the horizontal. The horizontal takes more heat, and you've got less likelihood for it to blow out. So where each one of these joints you're able to program to weld it how you see fit. Imagine just being able to, if you're doing it by hand, you'd be able to speed it up and do it more quickly as you're moving, kind of thing. So we ran the simulation twice and looked pretty good. There's entirely a possibility that this didn't come out perfect, but for only playing with this thing for like 1 day, I'm pretty stoked with this. Not too bad. Oh, ew, we missed right there by a lot. Whoops. I wonder what happened there. Just like we just ran off the part a little bit. Well, you know, whatever. First try. So we'll get some more bitchin' footage going on. All right, so I was making the video last night, and I noticed that I really didn't get any shots of completed welds. So here's the end. It's the end. So it's Friday afternoon. I've already posted a bunch of stuff. People are asking like, what does the penetration look like? Some things like that. So this process was developed by Fronius. They have like a CMT process, a LSC, some sort of stepped pulse process, and then PMC, I believe. Is like all these different processes that they developed. It has to do with like how the starting amperage or starting voltage is. So if they start the current off really low, it's easy to stabilize the arc. Doesn't make any BBs, doesn't make any spatter, and then they just ramp the power up. So for everybody asking about pulse welding, like Fronius has done all of this R&D. They've made all these processes, right? So this power source, this 400 amp power source. So I invite you to go on YouTube. They've done lots of coverage. They also do the CMT process that you can effectively weld razor blades together with. Really, really fascinating. I never heard of Fronius. I'd heard of Fronius, but I didn't realize. Like I just seen some things here and there. Knew they were red, and that was about the extent of it. But never really understood what was going on with it. So, in my efforts to expand the work catalog, or my parts catalog, and try to speed things up and actually have things in inventory. I would like to have powder-coated finished parts. I need to be able to weld them faster. And so we're just bottlenecked trying to hand TIG weld everything. So with having said that, I really had no interest in a lesser quality weld and a less visually aesthetic weld. So I basically knew like any of those, like that Miller cobot, no way, not with like a 252, MIG gun. Like that's just not going to cut it, man, between the bubbles and it's just not, is it bad? No. Is it what I want? Absolutely not. So I started looking around. I started off just looking at a robotic TIG, like a cobot arm with a TIG process on it. And although it would have been good, beautiful results, it's just not very fast. So, which was kind of like, okay, well, you can leave it unattended. It can weld a bunch, blah, blah, blah. So, but it's just really not faster, and it just it's basically a TIG torch with filler wire shooting out the side, right? Like it just, you got the arc, got the filler wire, it shoots in the side, right? So like still like a lay wire kind of process, and you could do all the pulsing and all that good stuff. So that's when I stumbled across THG Automation, and they have some YouTube videos, not a bunch of them, but just a couple of them. I ended up emailing Jimmy, and man, the quality is unbelievable, and so I figured I would take a couple of minutes to kind of show the quality of this stuff. In the video, you can see like this is the first parts that we've really programmed, and so we're still learning like what needs to be set at and some things like that. And we miss two joints, and you can totally tell. And it just shoots all kinds of BBs all over the weld, like it just looks awful. But I figured I'd at least show you kind of what's going on. Some guys were asking about some penetration, so we were doing the testing on the 3.5 inch 250 wall axle tube with the 3/8 outer bulkhead, and man, it's so nice. It's unbelievable, and it's really pretty fast. I posted a video of it, like maybe half of it, right? I don't know. The video's 30 seconds long or something, and it's just incredible. So I'm going to flip this thing around, show you guys some of the quality of this stuff. But yeah, that's where my mind's at, is I'm trying to speed this up. I want to lower the cost on the final products. But the only way to lower my main focus though is that if I'm going to lower the cost on the product, like I do not want a drop in quality of the product. So I'm not willing to sacrifice on any of that stuff. Quality needs to still be the same. So this was the answer to the automation end of welding, and it's not it is nowhere near the cheapest cobot you could weld. That is for sure, or buy. It's a UR20 universal robot arm. It has like 8 feet of spread, and then, like I said, it's this Fronius 400 amp power source with all the gizmos and gadgets on it. It wasn't cheap. Let's just go with that. Like, you can go look it up if you want to figure it out. So, all right, yeah. So that's where my mind's at. I feel like I've been rambling for 4.5 minutes, but whatever. gets the point across of what we're trying to achieve. I think this is a no sacrifice in quality. I can make them faster, and we're not going to lose any welders. Like, this is an augmentation, so we still, like, nobody's going to lose their job either. So everybody's still going to be working. We're just going to be working on other stuff. So I'm also really excited because I don't get a lot of time to R&D parts. And so if we're not doing as much welding, we can make new products. So that's really where my head's at with this. And I feel like if you're not automated on some of this stuff, like, you're just falling behind. I don't see how it's possible otherwise. So, all right, let's flip this thing around. Let's check out some cool stuff. All right, so the old Fronius gun got this push-pull stuff going on. You can see this thing is, there's my hand, like, this is a ginormous looking thing, whatever it does, but it pushes and pulls the wire, so it has something to do with initiating the arc, stabilizing the arc, putting the wire in, and then being able to retract it really fast. It also, you'll hear in the video, this little tit-tit-tit noise, and so what it's doing is you set this, this is fascinating too. That's all the debris. I've never put any nozzle goo in that thing. Like, that's just how clean the process is. At any rate, in the video, you can hear this tick, 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 tick noise, and you set the wire at 5/8 of an inch. It's basically like setting your Z-axis, right, your Z height. And if the wire touches, it retracts, and so it won't break the wire off. So you can just constantly know that you're at a good position, right? So that's what that noise was. So there's your UR20, Universal Robot Arm. Got the Sigma table that came with the machine, and then we also got a 4x8 table from Weld Table or Certiflat, and then I got every other hole done, tapped. So that's going to help a whole bunch with fixturing, right? So I have this whole thing drawn in SolidWorks too. So this is like kind of what I was testing with, because my goal is like, I'm going to do a little revamp on this housing stuff. I want to do the housing 100% with this machine. So this makes it, taking it from a, don't quote me on this, but, say a $2,000 housing like I kind of been at, I would like to come in at, say, somewhere between $1,400 or something like that, with all of the exact same features: drilled and tapped holes, beautiful welds, press brakes, 3/8 faceplate. Like, there is no compromise in this thing. It's just purely that we're more effective when we put these together. So, I mean, you can see that, come on, focus. There you go. It's basically perfect. So, like, you could wire brush it off, and it looks amazing. And so for everybody that was kind of asking about penetration, this shows really good. Look at that line inside of that tube where that weld is. It's awesome. Like, it welds. That's wild. Like, it welds it so nice, and the heat affected zone is beautiful. So, yeah, like, here's your, this was getting, and this is in the beginning. This isn't perfect. This isn't where we landed on Tuesday during our training, but you can see, like, the consistency is really good. This outside corner joint's a little bit big. It needs some work. But this is also with 045 wire. Like, I have all the drive rolls for 035 as well. That gusset, like, it's just, you just wipe the dust off into that thing. It's unbelievable how nice it is. So this was the plate from the video. This is just all kinds of just stuff that we had laying around that we didn't use. This was the stuff from the video, so you can actually see that we missed this side, and then we totally missed that side, and got all super ugly. But this is where all these BBs came from, because you can see this is the exact same program, because this program is different than this program is different than this program. So as you're welding, as the robot moves around, it's changing the program too. So the power source runs at different speeds and feeds, which is ultra trick. So you can see though, like, there's a couple little BBs right there, just nothing crazy. This side has those BBs. I noticed them in the video. I'm like, oh, that's terrible. But it's because it quite literally just fully missed. And it didn't miss because it missed. It didn't miss on its own account. It missed because we suck. So it's our first time getting started with this thing, and we're trying different things. That's going that way. Those beads are going that way. Whatever. Just kind of like feeling it out, seeing what we like. So I've got a lot of fixturing to do, a lot of things to make. Thank goodness I can machine parts. But so we were just playing with this over and over again. Some of these had a little bit of undercut, so we were speeding some stuff up, playing with some settings. But I mean, it's just incredible. So let's see. Here's another one. Looking amazing. Welded this one last night. The night before, we were showing Jesse and on our other buddy. Like, check that out. It was cool because we just took this one out. So we had that one. We welded that programmed and put this one in. Took this one, set it in this, and this is not what I consider bitching, right? Like, yeah, this table's super accurate and everything's great, but we didn't put these together with any kind of just the regular fixtures that we already have. And it's really just about setting the center line and then setting one side width. Like, we got to get a little more specific on getting this exactly the same. But you can see, like, it missed in the front and it missed in the front. Like, they are identical. And all we did was just move one over and put one back in. So yeah, so everybody was kind of asking about some penetration and stuff. Like, oh, look at you can see that. Look at the heat affected zone in there. Looking pretty good. So here's a little side-by-side comparison. So here's a TIG welded. I think this is an OBS bracket. Who cares what bracket it is? It's the same kind of thing. There's a TIG welded one. And then there's a Fronius welded one. I mean, to the sharp eye, you can tell, like, one process is not the same as the other process. But as far as consistency and accuracy and quality is concerned, I mean, it's just gorgeous. And so I wanted to show, too, that you could see, well, first off, look how consistent, like, there's a little bit of an extra HAZ there, heat affected zone. But you can see how incredibly consistent the heat affected zone is in the part. The outside's the same way. Right? And so we actually did this on two different settings. One of them's a little bit big. It's got a little bit of fall over. This one's definitely flatter. I can't remember what we changed, travel speed or something like that. There was a little difference in it. But this is like 45 seconds from end to end, right? This is like 10 minutes per side. So huge difference in the timing. Now, I mean, this TIG's still beautiful, like, obviously. But I think if this part showed up welded like that, and it was powder coated, or it just showed up like this is pretty... I'm super, super surprised how well this power source and whatever magic this thing's got going on, it's really bitching. So I think this part, what my goal is to be able to make these in such a way that I make more of them and make them faster and make them more economically. I can move the price around and also add, I really want to start powder coating stuff because I just think that it's so much nicer of a product at the end. So some of this stuff we're not going to powder coat still because it's race car stuff and it's like, oh, this doesn't fit. It's like, yeah, that makes sense. Well, good thing it's not powder coated so you can cut the shit off, right? So we can make some changes. So here's the pendant. You do all kind of programming from there. And then here's that power source. So it's a Fronius TPS 400i. So you can check that thing out, see what the options are. I think they go all over to like 600 amps or something like that, which is ridiculous. This thing is hot. Like, we're barely even touching down on this thing power-wise, and it's just beautiful. So, yeah, there we go. So that's kind of the... Okay, one last little... I found this other nice one. Like, we're definitely getting this dialed in. So look at the consistency across there. There's one little tiny BB you can see in the camera, and I'm zoomed in. That vertical down right there. The other vertical down right there. And then you can see heat affected zone there. Like, it's really, really, really nice. So yeah, okay. I'm going to insert this somewhere in the video. Imagine this thing powder coated. Oh, it'd be so good. So good. Okay. All right. There we go. So that's kind of the, that's the long story. guess it's a short story of a long story. Oh, another interesting thing. We're running on 9010, and we can run all the way up to 98.2. I intend on trying some other welding gases. 9010 versus 7525 is not even in this world. Like I cannot tell you how much nicer that 9010 is. Now, obviously, that's in correlation with this extremely exotic Fronius power source, but dude, 9010, wow, it's nice. It's really nice. So there you go. So there's the update. Hope you enjoyed it. If you didn't, whatever, can't help you with it. If you did, maybe throw me a like or a subscribe or something. Otherwise, yeah, we need to start making stuff. So until next time, catch you guys later.